Hi, everyone. We'll get started in just a few minutes. Hi, everyone. It is 2 o'clock now, at least according to my phone. So we'll go ahead and get started today talking about child language disorders. First, want to give you guys all a heads up about some upcoming due dates you have. So today, homework 3 is due at 11:59. And then next week, as always, before the exam, your review questions are due by 2 p.m. Remember, we're being kind of sticklers about not letting you submit them after the deadline. So try to get those in. It's an easy 4 points for you guys. And the quiz 4, opened on Tuesday. So it will be closing next Tuesday at 2 p.m. And then Thursday, you guys will have exam 4, and it will just follow the same format that it's been following, like multiple choice, true, false, that kind of stuff. So if you guys have questions on the exam, then like what it's going to cover, we can talk about that a little bit more on Tuesday. And then, of course, if you guys have questions on the quiz and on the homework, you can put those in the review question, and we'll go over those things on Tuesday. All right. So for today, it's going to be all about child language disorders. And there's a lot of things to distinguish when you're talking about language disorders in general. So we're going to spend some time just talking about the difference between things like primary versus secondary impairment, talking about delay versus deviance, speech versus language impairment, stuff like that. And then I'll show you guys what ASHA's definition of a language disorder actually is. So if you guys continue into the field of speech and hearing sciences, you'll be, really governed by how ASHA is describing these things. And we'll talk for the most of the lecture about what's known as specific language impairment, or SLI. It's something that I think if you guys go and become clinicians, you will deal a lot with. It's a really hot topic right now. So obviously there are other child language disorders, but we'll spend most of the time on this one, and then we'll talk a little bit about dyslexia and autism. And Oops, there's difference versus deviance again. I always do some error on these objectives. So yeah, clearly driving that one home. And then we will talk about some different accounts for what's attributing or what's the like underlying cause of SLI. And as I present these, I won't be doing the normal and here's all the problems with these, but there's really a ton of accounts out there. SLI is a very open field right now, and there's not a ton of answers. So there's some dominant research theories, which I'll briefly introduce you guys to. And then as you guys go off into the world, you can decide which one you agree with the most. Okay, so let's first jump into the different ways of talking about language impairments. So one of the main ways we can talk about language impairment is saying whether it is a primary or secondary language impairment. So when we say it's a primary language impairment, it means that it cannot be accounted for by any other etiology out there. So for example, if a child has, is going through their life and as their language is developing, if it seems like they are having some kind of like reduced ability to learn syntactic forms as they develop, but everything else seems okay. They seem pretty good cognitively. They seem, like happy, normal children. Then you usually would say that that language feature is a primary language impairment. However, we can also talk about secondary language impairments. And a secondary language impairment is just, I know there's a lot of words on here, but it's just basically when there's some other factor that can account for the language impairment in that child. So these are things like hearing impairment. So if a child is born deaf and isn't exposed to sign language early on in life, then they're going to have difficulty with language because they were deprived of language early on due to their hearing impairment. Or if maybe they have a common one is autism. So children with autism often present with language impairments. And when we talk about autism, I'm sure you guys have heard of it as a spectrum disorder. So there's really a range of where children can land on the spectrum. But we can say that a child has autism with a like comorbid language impairment where maybe they can't understand figurative language or something like that. So that's really the difference when we're talking about primary versus secondary is it the only thing that's going on with that child for primary, or is the language impairment caused by something else? Hopefully that makes sense. Feel free to ask questions as always if it doesn't. So this here, the IDEA, that stands for Individuals with Disabilities Educational Improvement Act. And this act was actually first put into effect in the late 1970s because prior to this act, children with disabilities could be denied access to effective education in public schools. So it wasn't a requirement that if they saw that they were falling behind and they had, in the case of speech, a language impairment, it wasn't required that they were given any services. And in fact, they can be removed from the school for that. So over the years, this act was put into place. And then over the years, there were many amendments to this act, with one of the major revisions being in 2004 during the Bush administration. And this act just kind of expanded these diagnostic categories. So traumatic brain injury was a big one added to these categories. And any child who fell within one of these impairments or disorders was required to receive support in school. So when we look at these 12 here, as they are, all of these would be considered primary disorders. So you see that speech or language impairment is on there, and that would be considered a primary language impairment on this list. But as you guys can imagine, if any individual was diagnosed with something else on this list and also had a speech and language impairment, then that speech or language impairment may be secondary. Just to illustrate that further for you guys. And you can kind of look through this and see how you can think of, like, maybe they have a primary speech or language impairment, but they also are blind. And so the speech impairment there most likely wouldn't be caused by their being blind. So there it would be primary. So you can have more than one primary impairment. Does that make sense for you guys? Hopefully it does. Okay, yes, thank you. So when we talk about primary language disorder, what does that actually mean? So according to ASHA's definition, you see this is from 1993, but it actually has not changed. I tried finding a more current version, and this is the one from 1993. So they describe a language disorder as impaired comprehension and or use of spoken, written, or other symbol systems. So the disorder may involve the form of language, so things like phonology, morphology, syntax, the content of language, so things like semantics, and or the function of language in communication, so things like pragmatics, and then any combination of these things. So when we look at this, you guys might recognize that ASHA's really looking at those component pieces that you guys learned about in the first half of class. So it's those things like phonological disorders, those things like difficulty with morphology, or like we'll see with SLI, difficulty with syntax. So a language impairment can really, or disorder can really fall into any of these categories, and it can include multiple forms of these categories. So you can imagine that it can get pretty messy distinguishing what a child has. And that's really a big, part of being a researcher in this field, is really trying to distinguish and understand these impairments. Okay, so far so good. All right, so the next term we will talk about is developmental versus acquired language disorder. So this came up when we were talking about aphasia. So the difference between developmental and acquired is that developmental, as it sounds, is something that a child is usually born with, and you start to notice it as they're developing language. And it's generally in the presence of otherwise normal development. So again, something like autism wouldn't be considered a developmental language disorder because it wouldn't suggest that there's normal, general normal development. That's kind of deviates from normal development. So when we talk about developmental language disorders, there are really three general classifications for these. So we generally, like with aphasia, how we could talk about fluent and non-fluent and comprehension versus production deficits. We usually, with developmental language disorders, talk about expressive versus receptive versus mixed disorders. So expressive is just how it sounds. It's really difficulties with production. Receptive is difficulties with comprehension. And then mixed is some combination of difficulty with both of these. We talk about an acquired language disorder. That's generally most of the time from stroke, so a stroke resulting in aphasia, or from a traumatic brain injury. The next term to learn about is something known as delay versus deviance. Curious, have you guys heard of this difference here, this delay versus deviance difference? If you could just put like a yes or a no in the chat, that would be great. Thanks, Marina. No? Okay. Some of you, a couple of you heard it. Okay. So this is, I only started hearing about this, I think, a couple years ago. So I think this is really something that's being kind of pushed in the research agenda right now, especially when we're talking about bilingualism, so that we really understand whether a language delay is due to actually having some kind of language impairment or due to like the fact that you have like two language systems that you're trying to work out and it's just a lot for a young brain, and so it's just deviating a little. So when we talk about delay, we're talking about a similar pattern of growth as typically developing children, but it's just a little bit behind. So it looks like the exact same trajectory, but it's behind. So maybe a 3-year-old is following the same trajectory as their 6-year-old sibling, but in terms of how they're acquiring things and the order that they're acquiring things. So we talked about the 1-word stage and then into this 2-word stage and then into having telegraphic speech. So they're following those patterns, but they're just doing it slightly delayed. So if their sibling acquired the 1-word stage at like 1.5, they'll be doing it maybe at 2 or 3. So that's delay. Deviance is a growth pattern that differs from typically developing children. So it's not following the same order. Maybe it's all over the place. It's not, 1 word then 2 word. It's not happening in that same way, that same typical developing way. And to illustrate this further, this is kind of the common way that people talk about it. I actually heard, I think a year or two ago, a grad student in my class talking about this, and it brought me back to my undergrad days. But so you'll probably see this if you go into grad school. But when we talk about delay, this would be train B in this image. So train A, we just imagine is a train that's, going on time. It has cart 1, 2, and 3 right behind each other. And this is just your typical development pattern for language. Now, for train B still has carts 1, 2, and 3 behind it, but it's just slightly delayed behind train A. So this is akin to language delay. And then finally, train C right here is not really an issue with being behind, but there's a gap between carts 1 and 2 and cart 3. So cart 3 is deviating from the rest. So if you imagine maybe cart 3 held the acquisition of past tense morphemes, then you can see that that normal pattern where they do this and then they do that and then the past tense morphemes, they're not doing that. Something's happening and there's some kind of weird gap right there. Does that make sense to you guys? Okay, I can explain a little further if I can't tell now if these no's in the chat are from, oh, thanks, Molly. Yeah, I'm like, are those no's in the chat from this or from something else? But okay, feel free to ask questions if it doesn't. Okay, so I have a question for you. Is, from what you guys know, do you think a language disorder is the same thing as a speech disorder? So yes, no, I have no idea, which is totally fine, or all of you just want it to be Friday, which I get. Yeah, so a lot of you guys are saying no. Nice job. So yes, a language disorder is not the same thing as a speech disorder. Cheyenne says, is it Friday? I hear you. We're almost there, guys. So yeah, a language disorder is not the same as a speech disorder. Well, let's look at that difference. It sounds like you guys are already a little familiar, so I'll just really drive it home for you guys. So a speech disorder is how we say sounds and words. So people with speech problems may not say sounds clearly. So they'll have some kind of articulation disorder, like maybe for the R's, like R's are really hard for kids to learn. Instead of saying red, they'll always say like wed or something like that, and well beyond the point at which a child should stop doing that. So that would be an articulation disorder, and that really just has to do with the ability of the speech articulators to produce that sound. Another example would be having a hoarse or raspy voice. So this would just be a voice disorder. maybe something to do with the vocal tract. And another example is repeating sounds or pauses when speaking. So something like stuttering would be considered a speech disorder. A language disorder has to do with the words we use to share or understand ideas. So people with a language disorder may have difficulty with various aspects of comprehension or of production or of reading and writing. So those are kind of the main areas in which we look for language disorders is in one of those. And just to really make it nice and difficult for you guys, although we are separating speech and language disorders, there are cases where a child could have both a speech and language disorder. And you can imagine a situation where one might cause the other. So maybe a child had to have tubes down their throat for a large portion of their life. So maybe they have a hoarse or raspy voice, and they also didn't get the chance to have a lot of input for language and produce speech. So maybe they also are delayed in their language as well. So can be both, but we try to distinguish them. Okay, so before we jump into talking about specific language impairment, which of these items here do you think has the highest prevalence in the US? So specific language impairment, autism, or dyslexia, or you don't want to participate and you just want the answer? C, dyslexia, some B's, some A's. Yeah, so pretty mixed results going into the chat. And that's fair. So let me ask you, it's not on this slide, but let me ask you guys a different question. Of these three, SLI, autism, and dyslexia, which one do you think is the one that, like if you go into the general population, the one that people would be most familiar with? SLI, autism, or dyslexia? Yeah, I think you guys are saying B or C. There's a good majority of B. Yeah, so overall, dyslexia, you're right, does, for those who said C, does have the highest prevalence, but the prevalence rating for dyslexia is a little misleading because it really depends on how narrow your definition for dyslexia is. So if you talk about dyslexia as a general reading impairment, then your numbers will be a lot higher. When we get to the dyslexia section, you'll see that it has a lot to do with phonological and phonetic awareness. And so as you narrow down that definition, the prevalence does drop. So for dyslexia, it's usually 5 to 15%, which is a pretty broad range. But for SLI, most estimates say about 7%. So when we talk about a very broad definition of dyslexia, SLI and dyslexia are really neck and neck. And then interestingly, autism is only about 2% of our population. Yet from your guys' responses, it seems like most people are aware of what autism is. Do you guys have any intuitions on why that might be? So if SLI and dyslexia are more prevalent, why is autism more well known?
I have a question.
Yeah.
When you say SLI, are you talking about developmental language disorder?
Yes, and I'll distinguish that for you. Sorry, guys. Yeah.
No,
SLI
it's okay.
and developmental language disorder are the same thing. And it's actually only around now that it's changing in the field. So I still say SLI. I've written more papers with SLI.
Can I try to answer your question?
Yeah, I see some people are putting in the chat, but yeah, I love voice interaction. That was great.
Could it be that children with developmental language disorder can fly under the radar of teachers and even their peers? The students tend to be maybe more quiet because their language isn't as developed, or they don't know how to express themselves. So is that why?
Yeah, that's spot on for why people hypothesize that SLI and dyslexia tend to be less known, is because when a child, even though autism is a spectrum disorder, so the range of autism can look a little different among children, but generally with autism, the impairment is more obvious. So it's a child with SLI, when you hear them speak, if to the fine-tuned ear, you might miss the fact that they're not putting past tense morphemes on words. And so, like you said, they really can fly under the radar. Whereas with autism, it's just a lot easier to identify. And, when you think of like the very stereotypical ideas of what autism is, that's much more noticeable out in the world than a child who is dropping morphemes in their language. And same with dyslexia, when we talk about it as a phonological disorder, that's a lot harder to notice when a child maybe isn't hearing the difference between but and duh compared to a child with autism. But yeah, I think a lot of you are kind of, you're talking about some stigmas and more research, more societal awareness. Yeah, so you guys are all on the right track, but it's just, this isn't for the exam, but it's just a really interesting dynamic to think of. And a lot of people in the fields of SLI and dyslexia are trying to bring more awareness to the disorder, because it does lead to a lot of like social just depression and stuff in these children. Someone said, I also feel like there might be more people on the spectrum than with SLI or dyslexia. It could be a thought that a lot of people with autism go undiagnosed as well. That's a good point from Maritza. If you're on a spectrum and you're functioning in day-to-day life, you might never get diagnosed. Whereas if you go to school and you can't read or you can't comprehend language, you'll most likely be diagnosed, especially at this point in our society. And then Emily asked, did I mention that the term SLI is shifting to DLD? Yeah, so there's a really big researcher in this field, forgetting her first name, it's Rice. So her name is all over SLI. She had this big paper about how, as a field, we really need to unify how we talk about SLI. And you see, I can't even stop saying SLI. I try to say DLD, but I still just say SLI. Because usually in the research realm, you'll see a lot of people still using SLI, but in the clinical realm, you see that shift much quicker to DLD. So DLD, I think the idea is just that it's a little bit broader of a term, and it really gets at the fact that it's a developmental thing, is because it's not really clear, like specific language impairment. Okay, so you have a language impairment that's specific to language, but I guess it's not as telling for what that means. All right, so without further ado, there's specific language impairment again. But as you see, let's see, I had a little note that for this asterisk that said also called DLD, but I think I deleted it from the slide for a second and forgot to put it back on, but you guys are spot on, also called DLD. So when we talk about specific language impairment, we're talking about an impairment that affects normal language development in children. And it can't be the result of neurological damage, hearing loss, or intelligence. And SLI has known genetic factors, but the underlying cause and the actual developmental trajectory is not fully understood. So a very open area of research if any of you guys are interested in. So there are a lot of mixed findings on neurological differences in these children. So we know that it's an underlyingly neurological issue, but it just hasn't been identified what's different neurologically. So some studies have found that children with SLI have reduced cerebral volume, specifically in this region. You don't have to know this region, but it's called the planum temporale, and it has to do with auditory association. So like taking in auditory information and mapping that onto all your like phonemes and then producing language. So that region's highly involved in that like integration aspect. And so they've found some that there's less gray matter in that region. But then other studies have said that there's not. So it's kind of all over the place. And then there's also some hemispheric asymmetries in brain function. So if you guys recall, we said that language was mostly left lateralized. Well, in children with SLI, some like fMRI studies have shown that they actually recruit more of their right hemisphere than typically developing children. But again, if you Google studies on that, you'll find just as many saying that's not the case. So it is really something that's kind of open in the field and not clear. Symptoms are not homogeneous with SLI. So all that means is that across different children, the symptoms will look different. So most part, they do think there's a lot of weight in the theory that it's has something to do with morphosyntax, but the symptoms don't look the same. So you can have expressive deficits, you can have receptive deficits, you can have this mix, which really adds to the difficulty in understanding it just because it looks so different across different kids. And typically it's not diagnosed until toddlerhood or when the child starts school, because until the child really starts producing language and having to understand more specific, like school-related language, it's not noticed. So that kind of goes along with what we were talking about with people knowing about SLI, is it tends to go pretty unnoticed for a long period of time. And typically to diagnose it, clinicians will use what's known as inclusion and exclusion criteria. So let's look at the inclusion criteria. So the first is that there has to be a delay in the language abilities that is greater than one standard deviation, that's the SD, below the mean for the child's chronological age. So let's unpack that a little bit. This is not a statistics class. You guys don't have to understand the bell curve and the distribution of the bell curve. But just so you can understand really what we're saying when it has to be greater than one standard deviation, let's look for a second at this bell curve. So this is just a distribution of scores. So if we were to take all of your exam scores from exam 3, which you guys did great on, the average exam score would fall right here, right in the middle. So rather than it being the average being like 60 something, let's say that the average of your guys' exam scores was 100. So this would be 100 right here. And a standard deviation, one greater or one less, would just be 1 unit away. So when we talk about something where the average is 100, the standard deviation is equivalent to 15. So scores, if this is 100, right here would be scores of 115, then scores of 130, scores of 145. And then similarly in the opposite direction, this would be 100, this would be 85, 60, no, that's, well, I'm not gonna do math that way, but
70.
Thank you. I was like, no, 60 is too much. So that would be a standard deviation in the other direction. So when we say that there needs to be a delay in language abilities that is more than one standard deviation below the mean, then we would say if children at maybe 5 years old, their language abilities for grammatical morphemes are here, then they would have to be one standard deviation below that in order to be diagnosed with SLI. And then of course they can fall even further down. But if they're anywhere in this shaded region here, then that wouldn't be considered SLI. But of course, you know, as a clinician, if you get someone that's like really close to this line, you should probably start keeping an eye on them just to make sure everything is okay. But we do have a child in our lab. We don't do SLI at the moment, but we have old data and was looking at their scores and they were like right on the line and I just didn't know what to do with them. Because I was like, oh no, do they have SLI? But that's one of the inclusion criteria. And then another one of the inclusion criteria are there has to be an absence of a frank neurological impairment or hearing impairment or some kind of social emotional disorder. So that really comes down to it having to be a primary language impairment. It can't be the result of something else like autism or not being able to hear for half of your life, something like that. And in addition, we say that your nonverbal cognitive ability has to be one standard deviation above your language ability. So all that means is that generally children with SLI are cognitively intact. Like if you make them do any kind of task that doesn't have to do with language, they perform just fine on it. But in order to be diagnosed with SLI, there has to be this difference between the language and the nonverbal abilities. So that just means that if a child is down maybe in this 13.5% range, their cognitive ability has to be at least one standard deviation above their nonverbal cognitive ability. And that's just because if a child maybe was down in this range where my mouse is and their cognitive ability was 2, that might actually be indicative that they have some other impairment. So that might be indicative of like, you know, maybe a child with autism that also has a language impairment. So in order to distinguish it as a primary one, it really has to fall into these inclusion criteria. Now with exclusion criteria, these are things that a child cannot have had happen. Well, I should rephrase that. I was gonna do a really like weird negative phrasing of it. Basically, if any of these things on the list were, you know, a reality of that child's life, then that would exclude them from being diagnosed with SLI. And not like exclude them, there's no possible way that they have SLI, but it's usually an indicator that it's not SLI, it's something else. So the first one is inadequate support of language development in the environment. So if you think back to like those feral children like Jeannie, or children who are born deaf to hearing parents and never get like proper language input, then that would really exclude them from being diagnosed with SLI because they just didn't have language support. So a child with SLI has adequate language input and has support in the language environment. They're just unable to attend to that information. Cultural linguistic differences. So I know I keep mentioning bilingualism. So this is kind of a big one, a hot topic right now, where you have to be really careful on making sure that a child's language is not one standard deviation below average just because they're learning 2 languages. So a lot of times children will have a primary language, like here in San Diego, there's a lot of children whose primary language is Spanish. And then when they go into schools, they all of a sudden have to switch to doing school every day in English when they had no input in English. And so when you look at a child at that stage, of course they're going to have differences in their language abilities. So we wouldn't automatically diagnose them with SLI. You'd have to, you know, watch their trajectory and make sure that it catches up to where it should for a bilingual child. Child can't have hearing impairments. They can't have any kind of neuromotor impairment or any kind of intellectual cognitive impairment. So what do you guys think the importance of these exclusionary criteria are? I think I've been kind of hinting at them, but I'm just hoping you guys can recognize what's the importance of using exclusion and inclusion criteria for a diagnosis. So I don't know if you guys are typing or you guys are like, dude, just give me the answer. I don't know. So I'll jump in. So The reason that we use these exclusionary criteria is just because in situations that fall within these criterion, it might be the case, yeah, good job, Marina. So it might be the case that language would have developed otherwise normally if these circumstances weren't in place. So you can't really disentangle a hearing problem from a language problem. So if the child might totally look the same when you test their language abilities if they had an early hearing problem and their language wasn't developing. But if you look at it in terms of exclusionary criteria, then you can point to the source of that language impairment. Whereas with SLI, as I keep on mentioning, we don't really know the source of that language impairment. Something neurological, but nothing else. Everything else seems fine. Nice job. Okay, so let's just look at some characteristics of SLI. So as we talked about a few slides ago, it affects 7 to 8% of children. Typically, the child will have delayed vocabulary. So I think a lot of parents get really nervous with this one because if their child's not picking up vocabulary and their friend down the road or their friend at the park is able to say slide and the kid can't, the parent really starts to panic. But we're talking about a very serious delay in vocabulary, not like months or, things like that. Delayed mean length of utterance. So you guys learned about that mean length of utterance last class where we look at the average number of morphemes. So this image was just taken from the slides from last class, and we didn't say too much about this, but the idea is that at different stages, children should be around these ages. They should be producing this amount of morphemes, and so you can kind of use this as a base to see if that child has a delayed mean length of utterance. And again, we're talking about a pretty serious delay. And then delayed marking of tense. That's a big one for SLI. So a delayed marking with ing on a verb, stuff like that. So moving to the accounts of SLI, this is going to get a little into that nitty gritty of the different theories. So I just want you guys to really keep in mind where these theories are coming from, kind of what the main idea is. I'm not going to test you on the specifics of these and the studies and all of that. So just try to keep the main ideas in mind with this. So some of the big questions that are currently being asked in our field is, do children with SLI have difficulties in just general processing abilities, which end up leading to language deficits or delays, or like the name suggests, is it something more specific? So you might hear of this as domain general versus domain specific. That's kind of that dichotomy, that argument. Do children with SLI have difficulties specifically with language, or is it just the grammar, or is it just processing of grammar? So really trying to figure out at what point in language, or is it just all of language that these children are having difficulties with? Are there different subtypes of SLI? So I said that there's a big range of difference for how these children can present. So some questions are asking, should we really be classifying like we do with aphasia? Should we say there's different types? Are there fluent and non-fluent? Are there mixed? Are they, how are we classifying these children? Severe, less severe, stuff like that. And then some people are trying to figure out the role of genetics. So research has really suggested that there is a genetic component to SLI. So if you look at siblings where one sibling has specific language impairment, generally the sibling, if they don't get diagnosed with SLI as well, sometimes you can see in their language that they are slightly delayed, but then maybe they'll catch up to their peers. But there does seem to be some genetic connection between it. And beyond that, I can't say what that is because I don't think we know as a field, but there's something there going on with genetics. So some of the accounts of SLI, they're listed here, and I'm just going to go through each of these quickly. They might kind of look scary on this slide, but they're really not that bad. So the first account for SLI is that there's a generalized slowing of sensory processing across modalities. So what this is suggesting that there's actually just some kind of neurological or like this developmental lag in processing, like sensory processing. So this can include like nonverbal cognitive deficits. This can include like motor movements and like auditory processing. So there's just kind of this overall overarching processing issue. And that would really fall into that like domain general. It's not just specific to language, but it ends up affecting language. So if you imagine that when you are hearing a word or someone talk and they're talking quickly and they're saying, yesterday I went out and sat in the sun and it was super nice. And man, I really wish that we can go outside and go to the park, not speaking from personal experience. That speech stream is really fast. And when I'm talking, there's actually really important markers in my speech that are pretty non-salient. So they're not really things that are, that we're picking up super easily in the language. They're pretty subtle. So these are things like your plural S and your past tense morpheme ED. So if you imagine that there's a general sensory processing deficit in SLI, then picking up these features of language would be pretty hard for them. And when we look at children with SLI, these are the things that we see dropped a lot. So that's where these researchers came up with the idea that there is this general sensory processing deficit. And in their study, they tested other processing aspects, sensory processing things like touch and taste and different things like that. And they found that children with SLI were just generally slower on all of those sensory processing things. So it included language, but also other things. And they all kind of clumped together, and it was different from typically developing children. The next account is a deficit in processing rapidly changing auditory information. So this has to do with like difficulty identifying rapid tone sequences or identifying, syllable boundaries. So this example, this image on the slide here, this is actually from a famous statistical learning study where I think they did it with adults, but they also did it with children, where people would listen to just like passively listen to this speech stream of like Polu, Taki, Buki, Go Bag, and it would just be playing in the background while they were doing something else. And then they were tested on the syllable boundaries of this language. And it's a statistical learning thing because people were able to pick up where the boundaries were just based on the co-occurrence of certain phonemes together. So, you don't have to know that to understand this here, but what the idea is that children with SLI would be unable to do that. So they have a lot more trouble processing, like breaking up that speech stream into the different syllable boundaries and, deciding which phonemes go together and stuff like that. The next theory has to do with reduced storage for phonological material in verbal working memory. So what does that mean? You have different parts of your brain responsible for remembering and processing certain types of information. And one of them is your phonological verbal working memory. So that's the part of your memory that remembers like the phonological sounds that you hear. So when you give a child with SLI a non-word repetition task, where you ask them to repeat these non-words to them, they actually have a really hard time remembering these words. And for someone who's typically developing, you can imagine if you are told to like repeat the syllable da, 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 as you tried to remember these non-words. So I'm saying da, 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 and then I'm supposed to remember and repeat, Perplisteronk and Blonterstapping. I'm actually going to have more trouble doing that because my phonological verbal working memory is kind of overloaded. And the theory here is that children with SLI, it's always overloaded. They have a reduced capacity for verbal working memory. So they have more difficulty remembering to put like their morphemes and stuff on words. And there's different ways that researchers have suggested this happens, but they've said that like verbal working memory deficits may be what causes SLI. They said it may be a consequence of just having SLI, or it may be some combination of both of these. So it's just not really clear if it's a causative factor or it's the result of SLI or some blend of that, which would be really hard to disentangle. So that's reduced phonological verbal working memory. And then I think we have two more. This is the inability to induce obligatoriness of grammatical rules. And this theory, first time I came across it, I was like, what the heck is this? Just because it has so many words. But basically all it's saying is that children with SLI will go through a period of only optionally marking tense morphemes much longer than typically developing children. So when you hear a young child's speech, you hear that sometimes they'll put that ed past tense morpheme on a word when it's required, and sometimes they won't. And that's just because like their system's working it out, learning to generalize it, all of that. But when you test a child with SLI, they seem to go through that period for much longer. So that's that extended optional infinitive, just meaning that they, for a longer period of time, they optionally mark morphemes for like tense and stuff like that. So to look at this, just to illustrate, I feel like that got very bright on my screen. This is a study where children were with SLI were compared to age match, that's that AM. So if they were 6 years old, then the age match group was also 6-year-olds, and then language matched children. So based on a number of different language assessments, they were matched on their language ability, but these language matched children were younger. I think most of them were around 3 years old. And what you see is that especially when you're looking at grammatical markers like ED, this 3S is third person singular, so like he goes, or the verb be or the verb do, which we use to like form a lot of our sentences, like, are you guys learning, you know, stuff like that. You see that children with SLI use it a lot less frequently than children age match and language match controls. So they just seem to go through this period much longer where it's optional to use these morphemes. Okay, I know these are a lot to take in, but again, just kind of keep the general ideas in mind. So the last thing is an inability to perform syntactic or lexical operations fast enough in real time. So imagine you got this sentence, the zebra that the hippo with tiny ears kissed, on the nose ran away. So at the offset of this verb kissed, there's actually what's known as a trace back to the zebra. So if I take this sentence and I make it a lot less complex and I say, the hippo with the tiny ears kissed the zebra. Kiss, or the zebra, is actually the direct object of kiss, but it just got moved to the front of that sentence. So in this cross-modal priming task, what would happen is children would see a picture of an animal. So it'd either be like a zebra or a hippo or just some random object. And they would see it flash on the screen right when they hear this word, the. And when it flashes on the screen, they're asked if what they see in the picture is alive or not alive. So if right here a zebra flashed, then the child would say alive. If like a cup flashed, then they would say not alive. And then the researchers calculated the time it took for the children to respond to the question. So basically right here, they were looking that if here you know that this is right here, people should be like thinking back to the zebra. It's called reactivating this noun here. Then because they have that noun in mind, when they see a picture of a similar noun, they should be a lot faster at responding. So that's a semantic priming effect. And when they compared typically developing children to children with SLI, what they saw is that typically developing children were much faster when they saw NP1, which is the zebra, compared to when they saw the hippo, because here they should have been activating zebra. So when they saw zebra flash on the screen, they were like super fast, like, yep, that's alive. And they were still fast at the hippo, but they were faster at the zebra. So these numbers are compared to how much faster they responded to one of these pictures compared to like the control picture, like a cup or something. So they were faster at hippo than they were at cup, and they were even faster at zebra than they were at cup. Now, children with SLI were not that much faster when they saw the picture of a zebra. And they were a little bit faster, weirdly, when they saw the hippo. So here again, they should be activating the zebra, but this suggests that maybe they're like keeping the hippo in mind. So they're putting the wrong noun phrase there. Interestingly, when the researchers slowed down the speech for children with SLI, the pattern shifted a little. So what this suggests here for the typically developing children is the slowed speech was actually a little like detrimental to their processing. They slowed down a little bit, but the children with SLI were faster at recognizing the correct noun phrase now. And then this minus 53 means they were actually even faster at the control than at the hippo, which suggests that the hippo now was like really throwing them off. They were like, no, it shouldn't be the hippo, because they had the zebra activated and they were like thrown off here because it's similar, but they're like, I don't know what's happening. So that's how this was interpreted. So what that suggests is that basically children with SLI, when you slow things down for them a little bit, they're able to process things a little bit better, suggesting that they just can't in real time do the type of like syntactic and lexical operations that they have to do, that typically developing children can do. But again, if you slow it down, they do a little bit better. Okay, so there's just a little fun fact sheet for you about SLI. So, you know, the next time we're allowed to go to parties, you can like bring this as your like super cool party knowledge. Just all these little things about SLI. So for dyslexia, I'm gonna cut these slides a little bit just for the sake of time, but we'll talk a little bit about what dyslexia is, just so you guys can understand the difference and kind of the misconception behind it. So dyslexia occurs in graduations, or you can say on a continuum. So like autism, it also seems to be kind of a spectrum disorder. And estimates for dyslexia for prevalence are again between 5 and 15%, but that can change depending on your definition. And dyslexia is persistent and chronic throughout a child's life, and it has a very strong genetic component to it. So unlike SLI, the research on the genetic component for dyslexia is a little more advanced, a little further in the field. Okay, just gonna take a drink real quick. All right, so the slide's blank right now, but when people think about dyslexia, they tend to think of dyslexia as just people who kind of like switch their B's and their D's around, or just, you know, get their letters a little mixed around. But it's actually a lot more than that. So I want you guys to think about the phonemes B and D and how similar they are in terms of their phonetic features. So when you look at these, or when you hear these sounds, B and D, what is the thing that's contrastive about them? Like what makes these two sounds different? You guys remember from phonetics and phonology? So B and D. You guys are like, dude, I don't remember. That was a while ago.
You mean like place of articulation?
Yeah, exactly. So people are saying one's labial, one's alveolar, place of articulation. So that's really the only feature that's kind of distinguishing these just like on their own without being in a like word or sentence. So now I want you guys to think about their shapes. Their shapes are really similar. They're only differentiated by their orientation. So for individuals with dyslexia, the core language deficit is actually really has to do with development of phonemic categories and the form of those categories. So that connection between the two. So understanding that this letter B represents ba and letter D represents da. So what happens for individuals with dyslexia is that those phonemic categories where they're storing all of that phonemic information really become overloaded. So the kids are really it's like suggested that kids with dyslexia are really paying too much attention to the phonetic detail that's not contrastive. So they might be like noticing features of but and da that are the same and not noticing that the place of articulation is different. So in like real time speech or when they're reading, when they're trying to track all of the phonetic information that they're coming across and contrasting it and mapping that onto letters, the demands of doing all of that become very high. So, mapping the phonemic representations onto the grapheme, so onto letters, are just going to become that much like harder for them to do. So you guys don't have to know this model. It's just to show that when you're mapping phonological information onto like semantics or onto orthography, what's really happening is you kind of have these like hidden nodes in your language where you're able to store generalizations about certain sounds and different rules for connecting sounds together and which sounds go together and which ones don't. And so it's really like deficits in holding that information together in order to like map onto the next level is the idea. So imagine if you're going from the phonological input for mint, so and you're mapping that onto the orthography. The rules for how M maps to would be stored in this blue node here, and that's what's disrupted in dyslexia. So you can see for a phonological deficit, that would be in like taking that phonological input and putting it into either of these orange nodes, you would have disruptions there. And that's typically what we say is going on for dyslexia. So imagine a word like phonological, where in the word you have 3 different instances of O, but 2 of those instances have an ah sound, so fa or sound, and one of those has phonology. I have to sound it out, and one has a different phoneme sound. So recognizing, we do this just effortlessly in language, we recognize that each of these instances in O has a specific pronunciation, but children with dyslexia have difficulty recognizing that. So if you're reading all these words and you have things like puh, where you know has different allophones, it might become really different or difficult for the child to recognize the sounds that they're reading and map those. And thus, that's why dyslexia ends up also being like a reading deficit, because it's phonological at its base, but it's disrupted such that it affects reading and translating those sounds to the orthography of the language. I just want to look at this question real quick. My roommate had chronic ear infections her entire childhood and is dyslexic. Is there any research supporting that hearing issues could affect the likelihood of dyslexia because of input issues? No, I think that's a great question. I don't know, but I think if she has dyslexia that runs in her family, I would assume that unfortunately that could have just been something she was bound to have since it is so genetic. But in terms of having a lack of input and then having dyslexia, I'm not super sure, but I would say that if at any point she started receiving more input in life, like maybe the ear infections like cleared up, generally I think she would like catch back up. So I think if she has dyslexia, that might have been something underlying instead. It's just my intuition, but that's a really good question. If you ask a child with dyslexia to do what's known as a phoneme deletion task, they're going to have a lot of trouble. So if you ask them to take the word spit, spat, spot and remove the S from each of them so that you say pit, pat, pot, they'll have a lot of trouble doing this because of that overall phonological deficit. So that's just one example of how that plays out. And they also seem to have poor verbal short-term memory. So if you test a child with a digit span test, where you say, you show these numbers, so 2, 7, 1, 9, and then you ask them to repeat it, they'll likely have a lot of difficulty repeating it because they'll have trouble holding that verbal information in their memory. And the same can be said when you do a non-word repetition task with them. So if they see blit, teff, poop, scad, and then you say, what did you hear? They'll be like, I don't know. I can't remember what it was. I can't even remember. I think that's sleep deprivation, blit, blat, bloop. I don't remember. But yeah, they'll have a lot of trouble with that. And then the last thing is they seem to have a lot of trouble with rapid naming because they possibly have slow lexical retrieval due to having to or struggling with mapping those phoneme sounds onto words. So if you were to say, okay, name this, this, and this, they would have a lot of trouble bringing out those words quickly. So they would probably stop it for a while on bird and pause for a little bit on apple and pause for a little while longer on tree. Finally, before I say like a few words about autism, I know we have 10 minutes left. I just wanted to show you the brain regions that are associated with dyslexia and with reading difficulties. So research has shown that children with dyslexia seem to have differences if you look at brain activation or amount of gray matter volume within these regions. So this parieto-temporal region that has the angular gyrus that we talked about, and they seem to have difficulties in that region. So that angular gyrus had a lot to do with translating phonemes to words for reading. They have difficulty in this word form region, and then difficulty in word analysis articulation region. So you guys don't have to know that, but just if you're like me and like looking at pictures of the brain, that's where it usually is. So a few words about autism. This is the criteria based on the DSM-5. If you're not familiar with the DSM-5, it's a diagnostic manual for various mental disorders. So it classifies mental disorders just using very common and standard language. And one of the criticisms of the DSM-5 is that not everyone looks like how they define it. So there's with autism, with dyslexia, with SLI, there's a lot of variation. But autism happens to be in the DSM-5. And when you look through, you can see that there's a lot of other disorders or issues, I guess, in white. But kind of the things relating to language have to do with a lack of back and forth turn-taking type conversation. They have difficulties with a lot of the nonverbal aspects of language. So understanding body language and the use of gestures within language. So, when we talk to people, we have, at least I do, use a ton of gesturing and stuff. So they would have a hard time picking up on those gestures. And there's, lack of eye contact. And there also seems to be a lack of like understanding figurative language. So again, very literal in their interpretations of things. And they have very uneven language development across different children. So um, often what you will see in children with autism is they have strong vocabulary in the area related to their specific interest. So this has a little bit to do with something known as perseverations, which is just like repetition of particular like words or phrases or like just really focusing in on certain things. So the things that they're really focused in on. So if they're really interested in astronomy, then they'll have very strong vocabulary, but not as good vocabulary in other subjects. Some of them can be early readers, others aren't. They tend to have inappropriate or rigid use of gestures, but again, these are all just like you can have them, but not everyone has them. Some has more, some have less. And then again, reduced sensitivity to figurative or non-literal language. So I think a large majority of children with autism struggle with non-literal language. They also tend to have imitative behavior. So this goes along with what's known as echolalia, where they'll often repeat what they hear or various like vocalizations of another person. So if you say like, okay, let's go, they'll be like, okay, 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 okay. And they'll just start repeating that vocalization over and over. And interestingly, this isn't specific to autism. You can see that a little bit with aphasia. I haven't seen a ton of echolalia, but again, we usually see non-fluent people. But you will see non-fluent people with aphasia perseverate a lot. They'll get like really stuck on a word. Like they would be like trying to say bed, and they'll be like bed, 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 and try it. Like they'll really perseverate on it. So children with autism do that as well. Pre-SMA is just a region in the brain, so this is what's associated with echolalia. So there seems to be some neurological differences in this region leading to echolalia. And then finally, children with autism use a lot of like scripting. So they kind of like have little scripts for everyday life. And a lot of clinicians will help them with these scripts so that they can maintain certain interactions. So for example, if an older child with autism rides the bus and maybe it's a city bus and they have to like show their bus pass, they'll have like a script for that interaction with the bus driver. So that is scripting. And that's just really a very like broad overview of ASD. So that's everything I have. It's a little early 3:10. I'm happy to stay on here if you guys have any more questions. Otherwise, I hope you have a great weekend. Don't forget to do your review questions, your homework today, and then the quiz next week. Thanks, guys.
Excuse me, Noel.
Yeah,
Hi, I had a quick question concerning some of the stuff we went over for specific language impairment.
sure.
So, what's the difference between, not the difference, I suppose, but so general neural mutra rational, however you say that, lag, reduced storage, that stuff, are those symptoms that if they present with the proper like inclusion criteria and without the exclusion criteria, is that how those all relate together, I guess?
Yeah, so all of these different accounts were based on studies in children with SLI. And you have all of these accounts because the field is just all over the place. There's not a huge consistent idea for what is causing SLI. But in this specific study, and tell me if I'm not answering your question, but
Okay.
for this specific study, they were just testing general like sensory processing in a group of children that had SLI. They compared it to age-matched, typically developing children, and saw that across all the sensory modalities, including things involving language, so like auditory processing and stuff, they seem to be slower than typically developing children. So the idea from this research group was that the underlying cause of SLI is the fact that there's this reduced sensory processing, and that's leading to trouble with language and all the aspects.
Okay. All right.
And
So are
then,
each, oh, sorry, I didn't mean
no,
to
go ahead.
interrupt you. Are each of these accounts then from a different study, or are they?
Yeah, so yeah, thank you for pointing
Okay.
that out. These are all different researchers.
Okay.
So in the corner, I have this one's from Kale et al.'s group, but there's a lot of studies coming out from like Rice and Wexler and all these different people. And the priming one was actually from our lab, but they're all different people with their like hat in the ring saying, no, this is what's causing
I
SLI.
see.
Yeah.
Okay. So these are different accounts based on research of a, a sample that are being applied to the larger as a possible solution or answer to what's causing or what the underlying uh,
Yeah.
issue is with SLI.
Yeah.
But they're not, I guess, ubiquitous enough to be considered the same as the criteria that were.
Right. So the criteria would be separate. So before any SLI child was in those studies,
They had to
they
meet
would
these criteria.
have to meet the
Okay.
criteria. Yeah.
Okay. Cool. That makes sense. Thank you.
Yeah, no problem. Okay. I think we're good. Carrie, I'll pop on over to office hours and see you in a bit.